Hello and welcome to Dimensional Analysis 1. In this video, we will recap our process for solving dimensional analysis problems and take a look at two more sample problems together. All right, so here's our plan. This was the way we were going to solve all these problems. So we're always going to start the same way. We're going to analyze that problem, look for information about what we're given, what are we starting with, what can we sort of imagine or visualize right in front of us, and what's the goal? What is the question that we're being asked? What is it that we're trying to find? What material, what units, that sort of thing. Then the heavy lifting will happen, right? So we'll have to make our plan to think about what are those connections, what are those relationships or conversion factors, what are those quantitative connections between where we start and where we're trying to go. Now remember, when we did this in class, not all of our plans have to develop from beginning to end. So sometimes it's easier to see how to do this problem starting at the end or in the middle. So we'll see how that works. There is no one right way. And this is the part of the plan where we're going to be applying all those fun new things that we know. Again, right now, lots of those things we know are things from definitions or things we've had to memorize. Eventually, as we go through the semester, those connections or relationships are going to be sort of moving up the difficulty scale. They're going to be things we have to think about and develop those relationships. They're not going to be simple things we've memorized. And then from there, we will then let the units do all the work. So we'll show our work. That's the dimensional analysis part, the using our units. Let the units tell us how to arrange those different quantitative relationships or connections that we've learned about. Then we will correctly operate our calculators to do the mathematical part of it, the computational part of our problem. And then we'll turn our brains back on and make sure that we're using proper significant figures and units, and then eventually materials as well as we move through the semester. So again, it's a quick recap of our process. So let's see how that works again in a little more detail for a sample problem. Okay, so here's our problem. A marathon is 26.22 miles, and the question is, how many centimeters is this? So if you've got your paper, hopefully paper, pencil, calculator nearby, you can pause the video, take a few minutes, and see if you can set this problem up. We've got our typical template here, so you can think about where we're starting, what our goal is, what is the question here. Develop a plan. How am I going to get from the units and materials and information that I start with to the result that I want? What units am I trying to find? Now, again, remember that plan doesn't have to develop from left to right. It can develop backwards or from the middle outward. And there's, again, often more than one way to do this problem. And then go ahead and try and solve it. Okay, so hopefully you were able to pick out that what we start with is the length or the size or the distance of our marathon run there. It's 26.22 miles. And our goal is reasonably clearly stated in our question, how many centimeters? So we're looking for centimeters. We're looking to change that distance from miles into centimeters. So we need to develop a plan. How am I going to get from a unit of distance in miles, which, as we know, is in our silly system of units that we use here in the United States, to the beautiful metric system units of centimeters in this case. So one way to think about it is because we have these two different systems of units, we know somewhere in there we're going to have to make a transition from units in the English system to units in the beautiful metric system. So you can think about what those relationships are. There are some that I promised I would always provide for you. There's plenty listed in your textbook. There may be some that you just already know. So those may be the types of relationships, connections, conversions that you're going to be planning to make first. So it may be different from what we see here. So I'll show you the way that I've approached it here the first time. So I spent some time living in Denver, and it's the Mile High City. So I know very, very clearly how many feet are in a mile. It's 5,280. So that was sort of the first thing that popped into my mind, is that I could get to feet. And then I remembered that I will always give you the conversion from inches to centimeters. So I knew I could get from my silly English system from inches into centimeters. So now my problem then was to get from feet to inches. And that is the example that we've been using through our class, that 12 inches equals 1 foot. So I pieced together all of those things. Again, it was based on my sort of experiences. You may have approached this a different way, and that's okay. But here are the conversions that I used. I used how to get from miles to feet. Again, that was based on a conversion factor that was just familiar to me based on where I have lived. We have our feet to inches, which is a pretty common one that we've been exposed to growing up with the system of units. And then the last conversion is the relationship between an inch and centimeters. That's a definition, right, based on how our English system is now defined in terms of the metric system. So these were the conversion factors that I was using. I've got 3 arrows, so I'm going to have 3 conversions to fit in there. So I'll start with my 26.22 miles, and I've got my 3 sort of parentheses, my 3 places set up, ready to accept those conversion factors. And I'm just going to let the units tell me which unit's going to go on the top and which one's going to go on the bottom. I'm going to arrange my units so that they are across from each other if I want them to cancel out from each other. Okay? Because units work just like algebra symbols. So my first conversion factor, I'm going to put the miles part in the denominator, in the bottom, because I start with miles. That's in the numerator. And my feet unit's going to be on the top. So that when I move to my second conversion factor, I want that feet unit, now that I've generated it, I want it to disappear. I want it to go away. I want to change it into inches now. So I'll again arrange the feet part of that conversion, 12 inches equals 1 foot, to be across from it where it was in the first case. So I have my 1 foot on the bottom and 12 inches on the top. And then in the third case, I'll arrange my inches again as well across from where it is in the numerator in the previous or green version. I'll put that 1 inch on the bottom and the 2.54 centimeters on the top. That is just strictly from using the units to tell me where they're going to go. I've kept the right number with the right unit. So I've started with some very true conversion factors, the ones I wrote down there under the arrows. And then I'm going to use them, right? Because remember, no matter which one we put on the top or the bottom, it's equal to 1. So it doesn't matter whether I put 12 inches on the top or 12 inches on the bottom or the 1 foot on the top. Those conversion factors are equivalent to 1, right? But what I want to do is choose a way to do them such that the units cancel out in a way to give me what I'm looking for, right? So they're not just increasing different units there. They're canceling out, and I'm ending up with the units that I desire. So we can see how the miles cancel. It's in the numerator initially. It doesn't look like it. There really isn't a denominator there, but you can think of it as being over 1. So the miles have canceled, the feet have canceled, the inches have canceled. And when I put all of those numbers into my calculator, I get this very long answer. But I do get units of centimeters still at the end there. So now I need to engage with my brain and look at significant figures. Look at those 4 there. So I've got 4 significant figures in my starting or initial or given value. All of those conversion factors that we used here in this problem were all from definitions. Definitions of what a mile is in terms of feet, definitions of what a foot is in terms of inches, and the definition of what an inch is in terms of the metric system. So my final answer should only have 4 significant figures since we're multiplying. So I can choose to write that in scientific notation or choose to write it in decimal form. But either way, it's 4.220 times 10 to the 6th centimeters. It's just a little less of a mouthful here. In order to show that that 0 is significant, it's a little easier to show it in scientific notation. And that's one way that this problem could be solved. But in class, remember we did several problems where we had a miles to kilometers conversion. So that might have been for you the first thing that you thought of in making your plan. Right? So this problem could have been solved in a slightly different way. Equally valid, and you'll get exactly the same result, right? Is you could have said, well, wait a minute, I know how to get from miles to kilometers. I can right away get out of the English system of measurement and into the metric system. And then you've made yourself a different, a smaller problem. You've reduced that problem to how do I get now from kilometers into centimeters? And given that those are both units that have a prefix on them, you know that the typical pattern is we'll use our knowledge of what the prefixes mean to go from kilometers to meters, and then to go from meters to centimeters to a different prefix unit. So that may have been the way that you chose to solve this problem, is to use the definition of a mile in terms of a kilometer. Right? So that's written out there for you. And then used your knowledge of prefixes to get the relationship between a kilometer and a meter, and between a centimeter and a meter. So these are all equivalent ways. You'll solve it exactly the same way that we did before. Okay, we've still got 3 conversions in this particular version here. So we can go from miles to kilometers, and then kilometers to meters, and then meters to centimeters, using those definitions again from before. And when we carry that all out, right, we can see that the units are going to cancel. We'll check that. Right, so we have just units of centimeters, and again, this is the value that our calculator gives us. And we'll check the same way with significant figures. We have 4 significant figures in our initial value, and again, all of those conversion factors that we used were based on definitions, so they're all infinite significant figures. So our answer should have, again, 4 significant figures. And surprise, surprise, we get exactly the same answer we got before, 4.220 times 10 to the 6th centimeters. Both routes, right, both plans, both ways that we got to that end result got us to the same end result, as it should have, right? They're representing the same phenomenon. We're still looking at the same distance to travel in that particular marathon race. So it should be exactly the same result. It shouldn't matter how we got there. But one of those ways may make more sense to you. One of those ways may have been easier for you to see and easier for you to develop. And again, both are equally valid and perfectly correct. So there's more than one way to do these. So your way might be slightly different from someone else's way. And again, as long as you're using true conversion factors and using them correctly, we should all end up with the same results. All right, let's try one more here. My car weighs 875 pounds. What is its mass in milligrams? Okay. You're going to see a lot of prefixes. A lot of them have M's in them, sometimes capital M's, sometimes lowercase m's. So we want to watch out for that. Make sure you know what those prefixes mean, how their symbols, what their different symbols are and what they represent. So again, pause the video and take a few minutes and see if you can set this problem up, identifying the beginning, what the question is, what the goal is, and make a plan from beginning to end, and then we'll try and solve that. Okay, at the start we have the car, and it has a weight of 875 pounds. And the question again is, what is its mass in milligrams? Right? So we're looking for a unit of milligrams. Both of these are units for how much this object weighs. So let's think about how we can get from pounds, which is again in our English system, to units that are in the metric system, milligrams. And there is, of course, a conversion between the English system of units and the metric system. And that is one I promised I would always give to you, right? So you can look that one up in your textbook, or it'll be in your notes or on the front of our exam. Right? So we do have a conversion that gets us from pounds, with its rather silly abbreviation of LB, to grams. That is something, again, that would be given to you. Then you've got to think, can I get from grams to milligrams. Is there a way to do that? Do I know how to do that? And the answer should be yes. Yes. The only thing different between grams and milligrams is a prefix. So you should be able to work with those prefixes and make those conversions. That's one of the ones we should have memorized. Okay, so I've got them all written down here so we can see them and then use them. So 1 pound is defined as 453.59237 grams. And 1 milligram, based on what the prefix definition is 10 to the minus 3 grams. All right, so let's get that set up. We'll start with our 875 pounds. We've only got 2 conversions here, 2 arrows, so we only need 2 brackets, 2 parentheses set up here for us. And now we'll let the units do the work for us. So our first conversion, we're going to have the pounds on the bottom, which is the 1 pound, and then the 453.59237 grams in the top. And then in the second case, our milligram is going to be the unit in the top, so 1 milligram in the top, and 10 to the minus 3 grams in the denominator. Now it's time to pick up our calculator, make sure we can operate it correctly. Always a challenge when we have powers of 10 in the denominator. So again, make sure you are operating your calculator properly. Okay, we'll check that the units cancel. And our calculator gives us this rather large number. And then the units, of course, are milligrams. We have to keep track of that. The calculator doesn't do that for us either. All right, so we should have gotten a big number, right? Milligrams are very small. We expect there to be a lot of very small units in something as large as a car, something that massive. All right, so we need to take a breath and think about significant figures now. So our initial value, somebody had to weigh that out, right? The car has a weight of 875 pounds. It's 3 significant figures. The conversion factors that we used, again, are from definitions, from a definition of what a pound is and the definition of what a prefix is. So we need to round that value that we got from our calculator to 3 significant figures. And again, it's probably easiest to do this in scientific notation. So make sure you're reviewing that if you need to. Okay. So it's either 397 million milligrams or 3.97 times 10 to the 8th milligrams. All right, well, thank you for joining me for Dimensional Analysis 1. There are a few other videos in this series for dimensional analysis, so be sure to check those out as needed.